So what we're going to do now, this presentation is intended to think about as you listen to me, but also to use this as a practical checklist for your own station. As you're designing a new tower and antenna system, as you're thinking about maintaining the system you have, there are ideas here for things that you ought to be thinking about during the installation and then following up on as time and the environment degrade the investment you've made in installing your system. And I'm not going to read these slides. There's a lot of material here, and it would take more time than we have, and a lot of you would get bored to death. So I'm going to just focus on the key points. I'm easily accessible for the entire weekend. I spend my time in the second floor contest super suite all through all the main nights of the convention. So if you have any detailed questions, you can always buttonhole me there, and I'll do my very best to reply to your questions there. And there'll be a little bit of time here, perhaps, for some questions, so we can follow up that way. But I want to hit the key point first. Hams are cheap. And this is the choice of tower sections. Is there anybody here that's not cheap as a ham? We're all cheap. And one of the places we try to save money, if we can, is to buy used tower sections. And most of us use tower sections with hollow legs. Well, let me tell you that when you buy those tower sections, or some ham is going to give you a tower, and you said you take that down and it's yours, this is one of the biggest mistakes you can make in your life. You don't know how that tower and those tower sections have been maintained. If the tower was properly installed, you don't know anything about the condition inside those legs. Be very, very careful. If someone offers you the opportunity to take down a tower, that might be the end of your life as you know it. Extraordinary care needs to be taken not only for the tower sections, but all the other aspects of that installation. So if a ham ever asks you to take this tower down for him and it's yours, or a ham ever asks you, can you help me replace that dipole 50 feet up my tower, spend some serious time looking at the safety of that installation to make sure that that's not the last time you're ever going to climb a tower. And the tower sections itself and other aspects of those installations in your friend's tower that asks you for a little bit of help could really be the last time you ever do this. So be very aware of corroded tower sections in any used tower or any tower anybody ever asked you to climb, or your own tower if some mistakes were made in the installation. And a couple of things to think about in the design is the load capacity to make sure you're not overloading things. And another thing a lot of hams don't think about, and I made this mistake myself in the design of my station 25 years ago. I have a lot of dipole antennas and quads and other things supported on ropes off the tower. Well, every time those ropes attach to the tower, it puts a unidirectional unbalanced load on the tower. Well, that's fair. So those forces on those wire antennas hung between these towers is only maybe 100 pounds. But I forgot to think about this. And about 3 years after I built my station, we got 1 inch of radial ice on everything, including these ropes. Suddenly, my 100 pounds converted to thousands of pounds, and the towers nearly fell down. So if you live in most of the United States where ice is an issue, you really got to give thought to that, especially if you have things hung off the side of the tower, like a dipole. Okay, so and in terms of maintenance and inspections, Not. It takes maybe an hour, once a year. You've got an investment in a tower and antenna system that's certainly thousands of dollars, in many cases more than that. We're all competitors. We wouldn't be here otherwise. What's the point in getting into a competition if you're not prepared? Go out there, spend an hour once a year, take a look at your outdoor antenna system and make sure nothing has happened. Another thing you should look at is just look straight up the tower legs and make sure the tower is reasonably plumb. For most towers, that means inches. And if you look straight up the tower legs towards the top of the tower, the lack of plumb and twist is readily apparent. You don't need any special tools to do that. Just use your eyes. And if you have several towers, you can compare the plumb of one tower to another tower. And if they're not exactly parallel to one another, something is wrong. And as you do your inspection, pay particular attention to anything that's not like it was when you installed it. Corrosion is particularly a factor on guying materials because the galvanizing is not as heavy as it is on a tower section. So regular inspections are the key to the long-term utility of the investment you've made in your towers and antennas, and it's really easy. One of the easiest things you will ever do with your antenna system. Tower base. The biggest mistake I usually see, and I would guess if my experience applies to the people in this room, and it probably does, I would guess about half of you have a problem here. And here are the mistakes that people make. You think, well, I'm not going to be in this house for a long time, so I'm going to put the foundation of my tower so the top of the foundation is at grade level or a little bit below, so when I sell the tower, I can sell the house, I can cover up the foundation. Disaster for the tower because all kinds of moisture is going to accumulate on that foundation that's at or below grade level. Or you don't pay any attention at all to the inevitable accumulation of debris at that tower base. If you haven't looked at your tower base in the last 6 months, it's a pretty good chance that you've accumulated grass, if it's in an area that you mow, that you've accumulated leaves, all kinds of other debris. All of that stuff retains moisture, and moisture is fatal to the tower legs, especially in a self-supporting tower that relies only on the foundation for its support. Doesn't take much time to go out and take a look at that tower base. And if it wasn't properly installed, or if the drainage is inadequate for any reason, it's very easy to retrofit that foundation, to put a concrete cap on it, to take away some of the soil in the immediate vicinity so that it drains properly. But take a look. Half of you in this room have got a problem here. And if you think you might, go out and take a look. If you haven't looked at your tower base in the last 3 or 4 months, take a look. Clean that tower base. It doesn't take but a few seconds. So these are the common things. Standing water on the foundation, that's usually a result of an incorrect installation. This happens just about anywhere. And settling and cracks can also happen, not as common though, but it can also happen. And the place you really want to inspect is the place where the tower legs meet the concrete foundation. As the tower begins to fail, you will notice that the corrosion, that the galvanization on the tower has started to fail right at that point where the galvanization hits the concrete. That's usually caused by debris accumulation or constant moisture, and that interface begins to fail. Guy anchors. Half the people in this room have gone to a retail place like Home Depot to buy their hardware for guy anchors. That is the wrong material to use, period. No exceptions. They do not sell the industrial-grade hardware that should be used on towers, exclusively, no exceptions. If you look at amateur tower installations, you will find all kinds of crazy stuff used for guy wire. You'll find all kinds of crazy clamps that are used to terminate the guy wires. You should be using materials that are acquired from industrial suppliers or ham-oriented tower sellers, such as any of the major companies that sell Roan tower, for example. They usually sell the proper accessories to go with that tower. Do not go to Home Depot or your other supplier. That's the biggest mistake you'll make when you walk into that place and try to find something that's good enough. It's not. And if any of you have any of that kind of material on your towers or your guy anchors, good project for this year to replace it all. Guy wires, clamps, all that stuff is completely inappropriate if obtained from a normal homeowner kind of a seller. So this hardware and guy wire is a big threat to the long-term integrity of, or even short-term, quite honestly, for some systems that I've seen. And this is not a rare case. It's a common case. Hams are cheap and they use the wrong stuff. And hams are cheap and they use the wrong stuff. And you save pennies. Almost no savings, and you put at threat thousands of dollars of investment as a result of a terrible decision. So this is the stuff to look for. It takes only a few minutes to do this. Yes, every so often if you have anchors that extend down through the ground, particularly if you're in a corrosive environment, if your soil is known to be corrosive, you should be doing this very frequently. If your soil is known not to be corrosive, every few years just take a shovel, dig down 6 inches. It doesn't take, when the soil is moist, it doesn't take more than a minute to dig down 6 inches and take a look. And anchor rod corrosion, I'll tell you a little story about K6LL. I went to college with Dave, and he was telling me about one day when he noticed one of his guy wires was loose. So it seemed rather odd, but he knew how to tighten the guy wire, went out there and tightened it, and the anchor pulled right out of the ground. And the place where the anchor failed looked like a point of a pencil. Just all of the steel had eroded away. He has very corrosive soil. You need to take very, very, very careful attention to guy anchors if you have corrosive soil. Again, the same story here with guy wire. You want to use the stuff that's sold by the company where you bought your tower, not Home Depot. It's junk for our use. Very important here. Many of us are aware of this recommendation for 10% tension. This is one of the reasons why you want to choose the right size of guy wire for your tower also. The tower manufacturer will recommend a particular diameter guy wire to be used with your tower. That is the diameter of the guy wire you should use. Certainly nothing smaller because it's not capable of withstanding the forces that you expect on the guy wire. But you also don't want to use a heavier guy wire either, because you will also have to tension that heavy guy wire to 10% of its breaking strength, and you are putting unnecessary extra force on the tower, which is causing the tower to be weaker. So you want to use the manufacturer's recommended guy wire. Tension it to 10% of breaking strength. If it's less than 7%, the guy wires are likely to gallop in the wind, to gallop as forces. As you get a heavy wind, the tower actually deflects. The downstream guy wire gets to be very loose. And if the guy tension is less than about 7%, you have excessive tower flexing and galloping guy wires. Not a good thing. And this is why you don't want to use guy wire heavier than the manufacturer recommended, because you have to have at least this. And if you're using, let's say, somebody had some 5/16 guy wire, it was cheap, I could use it free, had all the hardware, I put that on my Roan 25, you have to tension it to 7% of the breaking strength of 5/16 cable. You have no strength left in the tower. It's all been given away to the guy wire. In greater than 15%, you run into risk of vibration, and again, for no justifiable reason, you've taken away tower load capacity by excess guy strength, or guy force. In some environments, particularly environments where there aren't trees and other things to break up the flow of wind in the area, sometimes guy wire vibration is an issue. This can be particularly a case with fiberglass guy wires that are absolutely round, and some of the old Philly strand that's absolutely round. those guy wires will vibrate in the wind. If you ever see that, and the chances are you'll actually hear it first, you have to do something about that vibration. If you don't, it'll damage the tower. So if you ever notice this problem, it's a variety of guy dampening hardware that you can readily buy. You've got to do something about that problem. We'll take questions at the end. And again, corrosion is the big thing to look for. And in some cases, it can be real severe. You need to look at the guy wire, too, and you can do that with a pair of binoculars. This is particularly an issue if you use cheap guy wire, or somebody gave you guy wire when you put in your installation that was already beginning to corrode, so it's lost 10 years of its life already, and in the next 10 years it'll need replacement. And guy wire also has a lifetime of about 15 or 20 years when it'll need replacement anyhow. Guy attachment hardware. What I'm speaking about here is the mechanism that's used to attach a guy wire to a tower. If you look at ham installations, you'll see all kinds of crazy ways that guy wires attach the tower. The only way to attach guy wire to a tower is the way the tower manufacturer recommends it. Take a look at the Roan catalog. Most hams use Roan catalog, Roan tower, or whatever tower you're using. You should only be using the guy attachment mechanism that the manufacturer recommended. If you've used anything else, you've degraded the performance of your tower, and you don't know by how much because nobody's evaluated it. So if your towers are not using the manufacturer recommended guy attachment hardware, put it on your to-do list for this summer to change it over to what the manufacturer recommended. Fancy word, articulated guy wire connections. In the wind, your guy is, if you look at it, in a heavy windstorm, it is moving all over the place. And you want to be sure that the connections to the tower allow free movement of the guy wire in any direction. So what you need to be using and the manufacturers will all show you this in their catalogs, you'll want to use a shackle at that connection point so the guy wire can move up and down, left and right freely. And if there's anything you've done in your guy wire installation that constrains its movement in any direction, that force as a result of the guy wire not being able to move is going to get transmitted somewhere where it's not supposed to be, which is going to cause a problem over time. And usually the method that's used to assure full articulation in any direction, at least 10 degrees free guy wire movement, that usually consists in most installations of using a shackle at the joint so the guy can move in any direction. And also if you have trees or anything else that the guy wire can rub against, that's not a good thing. Something's going to degrade over time. If it's Philly strand, it's going to start cutting through the jacket. If it's steel guy wire, it's going to accelerate the corrosion at the point where there's some chafing. So that's something you have to look for if you have that problem in your installation. Turnbuckles should have safety wires. 75% of the people in the room don't have this. And it's dirt cheap. Maintenance and inspections. Take a look at when you climb the tower. Just remember, gee, in the process of climbing the tower next time to do some little job, I'm going to look at the tower to see if there's any missing hardware. I'm going to look at all the guy attachment points and make sure nothing funny is going on there. It just takes a few seconds as you climb past those guy attachments to make sure everything as it should be. And these are the simple things you look for. Very simple things, and I won't read them. Just when you climb the tower next, just take a look for all that stuff when you climb the tower and make sure everything is in order. Especially look for any broken welds on a Roan tower. If you have a tower that is very heavily loaded, that's one of the dangerous things that can happen, especially around the guy attachments, is that you can see a broken weld, and that's a pretty dangerous thing to find. And you really need to hire a professional guy to do something about that if you find it, and you shouldn't wait. Lightning protection. 90% of the people in this room have a problem here if you're in a lightning environment. This is what your tower should look like if you've done it correctly. There should be at least 3 guy wires, 3 ground rods located near the tower foundation, but not too close. About the length of the ground rod is the right distance for that guy anchor, for the ground rod to be placed. So if the ground rod is 8 feet long, which is what they typically are, those ground rods should be about 8 feet away from the tower base. There should be 3 of them. And then they should be about 8 feet from each other. Also, for the guy anchors, they should also have ground rods. 1 ground rod is sufficient. The preference for ground rods these days is to use a galvanized ground rod. The good news is galvanized ground rods are readily available. Why not copper? Well, the copper ground rod interacts with and creates a battery with the galvanized steel tower base. So, and that battery with moist soil, about 8 feet of moist soil between the copper ground rod and the galvanized steel tower base, creates accelerated corrosion at the tower base and also at the guy anchors. So the requirement for the current EIA specification is not to use copper ground rods anymore for tower installations. You should be using galvanized. And I'm not suggesting that you should run around and replace all of your copper ground rods, particularly if you haven't seen any accelerated corrosion problems. But if you're putting up a new tower, you shouldn't be using copper ground rods anymore. The galvanized stuff is easy to obtain, it's less expensive, and it's the right material to use. And the wire itself that connects the ground rod to the tower base should not be copper. It should be a tin-plated wire, which is readily available, rather than copper. And for the same reason, you have a battery situation between the moist soil and the copper and the galvanized steel tower base. And a very common problem, I would guess that 20% of the people in the room are using braided wire outdoors. Birds will attack it. It's great for building nests. The normal acid rain environment we live in today will ruin those wires. It's fairly rapid. And the other thing is lightning is RF. A very high proportion of the energy is at relatively high radio frequencies. And in braid, the RF has to cross every one of the joints in the braid. And as it corrodes outside, its performance is very poor. So if any of you have any braid exposed outdoors, put it on your list of to-dos to get rid of it. You should only be using solid copper wire or stranded copper wire, but never, never, never braid outdoors. Very easy to inspect your tower base to look for issues here. It's not uncommon for people who have lawnmowers or maybe an accident that might happen in climbing a tower for something to go wrong with the grounding system at the tower base. Rotators. This is the mistake most people make. Sometimes we'll encounter a heavy windstorm or something and realize right away that a mistake has been made. But the more common thing is that a well-designed rotator should give us 10, 15 years service without any problem. But with an overloaded rotator, you might only get 3 or 4 years service, and in the next contest it'll break. So you should be using a properly rated rotator, and I'd guess 20% of the people in this room are using a rotator that's underrated. The control cable should be adequate size. So you have to consider the length of the control cable to determine whether it is the proper size or not. Most manufacturers give a recommendation, and you should follow it. And this is a place where we commonly find stainless steel hardware on rotators. the U-bolts, for example, on the very popular tail twister rotator or the Ham series. This hardware is very subject to galling. And anybody who's used stainless has probably experienced this problem of just innocently putting a nut on a stainless steel bolt or a U-bolt, putting it on by hand, suddenly it won't turn anymore. And you get out a tool to try to turn it, and you can't turn it. Whenever you, on any stainless steel hardware, but especially on a tower where it's really hard to do maintenance, some inexpensive anti-galling compound applied to the threads, and the galling problem goes away. Also very easy to perform an inspection. Usually if there's some kind of an issue with your rotator, you can see it from the ground. Something has changed about the way that antenna behaves in the wind. So take a look at it. Very often it's caused by this kind of a problem. Okay. An awful lot of antennas are manufactured in California. An awful lot of those antennas don't survive on the East Coast. I wonder why. The ice environment on the East Coast can be pretty severe, and the guys in California don't even think about it. And particularly 10, 20 or 30 years ago when these antennas were first manufactured, they failed very quickly in the environment on the East Coast, and I think a lot of the manufacturers have figured out that they want to sell these antennas and have happy customers on the right side of the map as well as on the left side of the map. So this has gotten a little bit better, but you have to think about a commercial antenna as well as a homemade antenna as to how well it will survive in ice. I've had some pretty bad experiences with this, but I also paid a lot of attention when I was in kindergarten. So when things fail, you make them bigger and bigger and heavier until they finally don't fall apart. But let me tell you about some of my experiences early on. When I moved my location about 25 years ago, I moved to a much higher elevation, and I did not anticipate the effects of ice. Well, think about it, and the first thing you think about, well, that's a lot of additional static load. That's true. Pretty good chance it'll survive the static load. But the ice comes off your antenna, doesn't it? It doesn't stay there forever. And if you watch what happens when the ice drops off an antenna, it never drops off symmetrically. It drops off on one side of the element first. And you have tremendous unidirectional loads as the ice drops off. So usually if you're in an ice environment, about 45 of the 48 states are in an ice environment at some point or another. If you're in an ice environment, you've got to think about the mounting hardware so that it will survive very high unidirectional loads as ice falls off of a Yagi antenna. The forces are enormous. I mean, just think about an ice-loaded antenna, and the first piece of ice, and it's a pretty good chance, drops off the end of one of those elements. Just think about the force that's applied to the antenna by all the other ice that's still there, and some piece of it has dropped off. So you have to really pay attention to what can happen. Vibration is also an issue. And if you see your elements vibrating in the wind, it's not going to be too long before you see that piece of an element sitting on the ground. So some manufacturers take care of this in the design of their antennas. But if you ever see this problem, you've got to do something about it because it's going to lead to a failure. Just like singing guy wires lead to a failure of the tower, vibration, and it's the high frequency vibration that's the real threat, not just galloping, but vibration enough so that if you put your ear on the tower, you can hear it. Or if you look at the antenna, you can see that it's vibrating very rapidly. You've got to do something about that. So know your conditions and do the right thing in the installation, and pay attention to what's going on. Now, in my next presentation, I'm going to speak a lot about coaxial cables. Well over half of you have got problems in your coaxial cables today, somewhere in your station. And the most likely place where your problem exists is at the connector interface to the cable. Most hams use the wrong connectors. You can go out in the flea market and for $2 you can buy a cheap connector for your cable. Or you can go to any number of sources on the web and buy the Amphenol 83-1SP connector, which is a very high quality connector, and it will survive. But this other junk, and probably more than half of you are using the wrong PL259s, lead to problems of all kinds. They're difficult to solder. Many of the foreign-made components have the improper tolerances on the center pin in particular. So if you're not using Amphenol 83-1SP PL259s, very good chance you've got a problem in your system. I'll tell you another place that's very common. Does anybody use LMR 400? Anybody? Okay, so for those of you who use that cable, do any of you have soldered connectors on those cables? So there's 2 people, 3. Okay, so here's the situation with LMR 400. All of you have got a problem. All of you should be addressing this year. And here's the problem. LMR 400 has 2 shields. One shield is a metallized foil inside, and the other shield is a braid on the outside. So one of you who has a soldered connection, give me the answer to this question. What do you think has happened to the metallized mylar foil, and that's the one that carries the RF? What has happened to that foil when you solder that connector? What do you think? It melts. Right. So every one of you that uses LMR 400 or any other type of cable that has a metallized mylar shield, if you've used a soldered connector, get rid of it. You've got a problem. You don't know where the actual RF flow is. Here's one thing you know for sure. With that metallized mylar shield, for most of the cable, the RF is flowing on the inside of that metallized mylar shield. That's a good thing. But at the connector that you've soldered, where you have definitely damaged that metallized mylar foil. The only question is how much you've damaged it. You have damaged it. You do not know how that RF on the inside of that mylar foil is making contact with your soldered connector. You do not know. And it's probably not a good story. And it gets worse over time. The only connector to use is the one the manufacturer recommends. Not some of the connector manufacturers, the one the cable manufacturer recommends. And without exception, the cable manufacturers recommend that you use a crimp connector. So anybody using LMR 400 or any other type of connector cable with a mylar metallized inner shield, if you've got a soldered connector, cut it off. You have to cut it off far enough back so you find the mylar inner shield is not damaged by heat, and then put a crimp connector on. If you're not sure how to do that, find somebody who does. In most ham stations, the place most likely to be improperly done is the interface between coaxial cables and connectors. Either because the ham has chosen the wrong connector, which more than half the people in this room have done, or they don't know how to install it, you've got a problem. And the problem could arise at any time, particularly when you're in the middle of a contest when none of us want to deal with that. Or as you're entering a contest and you wonder, Gee, I wonder if anything's going to break. I wonder if there's something that I made a mistake with. This is probably the place where most people have made some sort of a mistake. Attachment of coaxial cables to towers. As the wind blows, as the ice accumulates, the coaxial cables or control lines attached to the tower undergo a lot of stress. The coaxial cables should be fastened to the tower at regular intervals so they are not slapping against the tower and all kinds of places on the tower where damage could occur. And the appropriate kind of hardware should be used to attach coaxial cables and control cables to the tower. And one of the best ways to do this is a very, very cheap way. Number 12, insulated copper wire, the kind of stuff you see in normal house wiring. Number 12, insulated copper wire is a very good twist. It's like a twist tie. You use that to attach the cables to the tower. It works very well. A nice thing about it is if you need to remove it, it's very easy to remove, and you can reapply it at least once. We use tape, use a high-quality tape such as Scotch 88. That's the most resilient. It's thicker, or Scotch 33, but you wind up using more of Scotch 33 so you don't save any money. 95% of the people in this room do not have their coaxial cable shields connected to the top of the tower. Why? Why is this important? In a lightning strike, and if you live in a lightning area, you're going to get lightning strikes. There's a tremendous amount of current that flows down the tower and down all the cables. If there's a voltage differential between the cables and the tower, and there's thousands of amperes flowing, so there could be a differential, what will happen is that an arc will occur between the cable and the tower. That arc will perforate the jacket of the cable, and you'll never notice it. But what will happen? Moisture will begin to penetrate that cable and degrade it, and you won't even know. And you can eliminate that problem by bonding all of the cables at the top of the tower. It's not practical to do that really with control cables, but certainly the shields of the coaxial cables should be bonded to the top of the tower and at the bottom of the tower, and then that voltage differential between the two is not enough to poke through the jacket of the cable. So let's let the questions wait till the end. Okay. So how do we tell if something has gone wrong with our coaxial cables? I would guess 50% of the people in this room have at least one cable in their station that has degraded over time. And how do you know? Well, make an investment in one of these tools. Certainly, with modern transceivers, everybody's got a VSWR meter of some kind in the transceiver. Another very good thing to obtain is something like an MFJ 259. A lot of us have that. You can buy time domain reflectometers on eBay for a few $100s. Anybody with a serious station, it's worth investing a few $100s in a time domain reflectometer that'll allow you to examine the entire length of your cable system, including the antenna that it's connected to. Or for more money, a vector network analyzer that only the most serious people will invest in. But with any of these tools, from something all of us have to something inexpensive for all of us to obtain, to more sophisticated things, these tools allow you to detect degradation over time. If any of the measurements you make change, something's gone wrong. Something has not gotten better if the measurements change. So I would encourage all of you who have not made a record of these measurements, and it's a good idea on each band to make a measurement of VSWR at the band edges and in the center of the band, make a record of those, and once a year go back and take a look. If something has improved, VSWR has gotten better, and typically that'll happen if the coax cable is degraded, something's wrong, and it's time to pay some attention to it. Don't celebrate because the SWR has gotten better. Something's failed. So good record keeping here. This is easy. This is simple stuff. Doesn't take long. And this kind of simple stuff will detect the degradation that more than half of you have. Okay, so I think we have, well, I don't think we have much time for questions, maybe 10 or 15 minutes. Hopefully this presentation has given every one of you an idea of something to look for to improve your tower system that's only going to take you a few minutes to execute. A few minutes to think about when you invest in the next tower or an antenna you're going to install. And it's going to make a significant difference in the performance of your antenna and tower system over time. Inspections are the big thing that most people don't do. Most of you don't do it. And it's really, really easy. It's not in the ham vernacular to do that. And it's so simple to do. Think about inspections when you climb the tower. When you're outdoors, bring out a pair of binoculars and take a look at what's going on with your tower. It's essential to the long-term survival of the tower and the reliability and performance of your antennas. Do the inspection in the first year after you build the system or any major modifications, then at least every 3 years. If you're in a severe environment, it should be more often than every 3 years. Do those measurements inside your shack in the winter when you're wondering what to do with some spare time. Takes only a few minutes. Make a record. And after serious storms or when that tree falls on the guy wire, do a major inspection and make sure nothing escaped your purview. So that's the end of the presentation. I'm sure you have some questions. I think the gentleman in the front here had one. I'll just ask one question, please.
When do you look at in-place coax? I know it's different environments.
And the other thing I'd like each of you to do when you ask your question, if you just identify yourself, because perhaps someone might want to follow up with you. Some of you in the room will be able to give better answers to some of these questions than I can give. So would you identify yourself, please?
I'm K5HAB, Peter Mauer.
Okay. Thank you, Peter. So the question is, how often should you replace coax? If you've selected the right coax and you've installed it correctly, the correct connectors, protection from moisture intrusion, grounded at the top and bottom of your tower, attached to the tower frequently enough so that it doesn't bang against the tower in the wind, you should expect 20 years of life from your cables. 20 years. Now, there are some very cheap cables that will not last that long. But if you buy from any of the major manufacturers, from any of the reliable ham dealers, they sell good quality material. It'll be Amphenol or Belden or LMR 400 is a fine cable if it's properly installed. If you've done everything right, you should expect 20 years. If you've made mistakes, you might not get 3 months. And it's real easy, all the way in the back of the room. And I'm only going to take one question, Alan, because there's a lot of other questions, so I'll take the first one. How do you know if the inside of the tower has been compromised? One thing to look for is to take a look whether if you're going to take down a tower from another ham. First of all, you're going to go over there and take a look to see if it's safe to put your first foot on that tower. So you're going to look at the installation. Corrosion inside tower legs is usually caused by lack of drainage. And unfortunately, for most towers, that drainage happens inside the tower foundation, so you can't see it. So about the only thing I can suggest to you is if it looks like that installation was kind of done on the cheap, be real suspicious. Okay, how to protect your tower, okay. Well, in your case, if you've already installed the tower, then the question is, did you provide drainage at the bottom of those tower legs so that when moisture gets in it, and moisture will get in to the interior of those tower legs anytime there's a big temperature change. And the air inside the tower legs condenses onto the legs and water accumulates pretty rapidly. So if you install the tower so that that water drains reliably, you're probably fine. If you haven't done that, there's a pretty good chance that you've got problems with that tower, and it's going to get worse with time, and there's not a lot you can do to correct it. Yes, right here. Question is, what's the value of cold galvanizing spray? There are lots of different manufacturers of that material. Some of the industrial grade versions, and also the Rust-Oleum version, are pretty good. The thing that there are two aspects of cold galvanizing spray. One is how much galvanized is actually put on the tower, and the other is what's the material that adheres that cold galvanizing spray to the tower. And for homeowner stuff, the Rust-Oleum brands are pretty good, and there are industrial brands if you go to places like McMaster Carr, and it does work. It doesn't last forever. If you get 5 years out of it, you're doing pretty well, and then you can go back and correct it. But all of the, for example, in the industrial world, there are lots of companies out there that galvanize bridges and all kinds of industrial materials. Accidents happen even during the transportation of those materials, and they do use cold galvanizing to correct it. So it's a common thing, and if it's done properly, it's a good quality repair. Nothing to be concerned about. All the way in the back over there. Yes, go ahead. Yeah. Okay, so George, let me see if I've got this right. You're getting ready to install a tower, and you got the tower sections laying on the ground. What do I have to do to assure that the tower sections are going to mate correctly and that the electrical continuity is provided between the sections? To use tower. Okay, good. First of all, on the ground, be sure that lay out the sections the way you intend to install them in the air. And make sure that you can mate those sections. And if you can't, you're going to have to use some sort of mechanical leverage to bend the tower sections a little bit so that they mate easily on the ground. Believe me, if they don't mate easily on the ground, you will be really sorry trying to put those together on the tower. And even worse than that, someday you'll want to take that tower down. And if they didn't go together easily on the tower, they'll be a bear to get apart and dangerous once you try to get those sections apart. So lay the sections apart on the ground exactly as you intend to install the tower and make sure they mate properly. And every tower I've ever seen does not require any kind of strap or anything else to connect them electrically. The joint will do that. And with galvanized towers, there's no need to put any grease or anything else on those. Just be sure that they mate correctly on the ground. All the way in the back of the room. Todd. Well, basically, the same mechanism that you use to connect, to bond the cables to the bottom of the tower, you can use exactly the same mechanism that you use to bond the cables at the bottom to the top. There's a variety of ways to do that. For flexible cables, a popular way to do that is to use PL259s and a barrel connector, and then to run that through a piece of angle aluminum, and then that can be used as the bonding mechanism at the top and the bottom of the tower. 2 PL259s, a barrel connector, and then connect that barrel connector to the tower. That's one way. Well, I'm sorry to hear about that. So here's what Todd, see, Todd's trying to impress me. See, Todd's a good friend of mine, and he does a lot of things right. But like everybody in the room, we all make mistakes, including my tree that fell on my tower. That was a mistake on my part. It wasn't the tree's problem. End connectors are an extremely bad choice for a connector. They're an obsolete connector. No professional uses them anymore. Why are they a bad connector? Because the mating force between the pin of an end connector, the male pin, and the female socket, that mating force is very weak. And over time, it gets weaker. And if you install your own connectors, they weren't professionally done, chances are the tolerance of the location of the tip of that pin relative to the end of the connector is extremely critical. If the pin is recessed just a few 10,000ths of an inch too much, the mating force goes way down from an already inadequate mating force. And if the pin extends outside the end of the connector by just a few 10,000ths of an inch, it'll damage the mating connector. It's a terrible connector for ham use. We shouldn't use them. For HF use, even on 6 meters, the very best connector we can use is the Amphenol 83-1SP. Any of you who've got end connectors in your HF station, get rid of them. It's a terrible connector. We can tolerate them on 2 meters and above, but there's even better choices than that. And on Andrew Heliax. Andrew Heliax is a fabulous coaxial cable. And you can often find Andrew LDF4, the half-inch diameter Andrew cable, and that's probably what you have on your tower, in flea markets and other places for about the same price that you pay for RG213. It's a fabulous cable. And the connectors that come with it are very high quality. Unfortunately, Andrew does not sell a PL259 connector for LDF4. But there are aftermarket suppliers of excellent PL259 cables, connectors for that cable. One of those is our favorite supplier, Todd, RF Connection in Maryland. So, you know, the PL259 and the end connector both date from about the same period of time, just before World War II. One is a fabulous connector for HF and one is horrible. And you all know which one is which. At the back of the room again. Okay, Steve has a self-supporting tower, and of course these issues are very critical for a self-supporting tower. There aren't any guy wires to help compensate for problems at the tower base. His tower is only being held vertical by the attachments of that tower to the foundation. So if you discover corrosion at your tower, at the tower base, whether it's a guide tower or self-supporting tower, a very practical thing to do is to sandblast away that corrosion. You only want to take away the corrosion, not any of the metal. So use sandblasting or any other approach you might use. You can go to a rental company and get the sandblasting equipment in the sand, get rid of the corrosion, and then use one of these cold galvanizing materials and cover that corrosion over. And then, in your case, since that's so critical, after you've painted it, it's a good idea to take some tar or something like that and cover it over. But that's for a self-supporting tower, that foundation is absolutely critical. And when you find something like that kind of corrosion, you need to do something about it. And for people with guide towers, if you find corrosion at that interface between the tower and the foundation, many of you in the room have this problem. Rent a sandblaster, get rid of that corrosion, cover it with cold galvanized paint, and then cover that over with roofing tar or something like that to keep the moisture away. Yes, right here.
Yes, sir. Doug, how do we determine the corrosiveness of the soil?
How do you determine the corrosiveness of the soil you're dealing with? In the case of your own kind of microclimate, the only way you can find out is a professional guy. But chances are the problem that might exist in your area exists over a wide area. So if you talk to an engineer in your county building department, they'll know about it. And they'll probably know in the particular area of the county where that problem exists. Another question, right here in the front.
Question concerning tower grounding. Now, I'm Ben's K4JC. I understand that the ground system for the tower should be tied in with the grounding system for your shack.
Yes.
But what if the tower is a long way away, like mine is 160 feet from the shack? Do you still tie?
Yeah, okay, Vince. Well, 160 feet isn't a long way away. That's pretty close. When you're building a new station, a lot of us will dig a trench. A few inches is enough, sometimes more than that. And a good thing to do when you're building a new station to bond the tower to the station grounding system is just to put a bare wire in the bottom of that trench. And it doesn't have to be a very heavy wire because not a lot of current is going to flow in that wire. So just heavy enough so that it's mechanically going to survive over time. So like a number 12 bare wire buried in the trench before you put the cables in. If you have a conduit, don't put the wire in the conduit. That's the wrong place for it. It should be outside the conduit. And I think it's, after the fact, you could also dig a shallow trench and just bury a bare number 12 bare copper wire to connect those, to bond those two systems together. The next row.
If you get the lightning protection grounding wire, that stuff is very close to the soil. You can lay that right in your trench as well. People do ground lightning wires.
Yep. Okay, yeah, the professional lightning protection people have fabulous products. Another question, the third row. How can you measure guy tension properly? There's a couple of easy ways to do it. If I walked up to a guy wire and I wanted a rough answer to that question, all I have to do is put my hand on the guy wire and pull it, and look how the guy behaves. If there are multiple oscillations in the guy wire, in other words, it's slack, and I see multiple peaks and minimum in the guy cable as it moves as a result of stressing it, it's probably under tensioned. If I tug on that guy wire and it's difficult to get it to move, chances are it's over tensioned. So that's a simple thing you can do just by putting a hand on the guy wire. Not a very precise way to do it, but chances are if you can induce motion in the cable by pulling on it, it's probably not over tensioned. And if it only has a single deflection, kind of halfway up the guy wire, and not a bunch of deflections, it's probably not under tensioned. If you want to measure it, there's something called the loose tension gauge, LOOS. You can get it from sailboat supply companies. It's accurate enough for ham use. And if you're a perfectionist, there's all kinds of professional stuff, but it costs hundreds of dollars, and you have to know how to use it. I'll take one more question. Let's see, Alan, you've already asked a question. Over here. Oh, okay. Question is aluminum towers versus galvanized steel. So let me tell you a story, and I'll leave it at that. One of my good friends is K3CB. He lives on the eastern shore of Maryland in an area that has a relatively benign environment. One day, relatively calm winds, maybe 10 or 20 miles an hour, his wife came running to him to tell him that one of his towers fell down. And it was a Heights aluminum tower. The tower was improperly manufactured and the welds were not done properly. And just the normal wear and tear of the tower snapped a few of those welds, and in a light wind, the whole thing came down. It's very difficult to manufacture aluminum towers that will survive. So I don't think very highly of them, and that's my answer, and a real world thing that happened. I think we're at the end of the time. Folks, any of you who have any questions you want me to answer, I'm real easy to find and I'm easy to talk to, so I'll be happy to answer your questions at any time over the weekend. Thanks very much, everybody.